So now let's try to evaluate the Rmse, right? Because we just filled out the table, so let's see how good we did, right? So we have to figure out how to do the Rmse, and we'll walk through this now step by step. Just so you know, this is the most math that we will do in this course. I think in the PageRank lecture we also did a little bit with simultaneous equations, but this is the most complicated it will get. From here on out, the next 3 lectures we'll do little to no math. We'll be back to just arithmetic, very simple arithmetic. But here, just bear with us. We'll be fine, and we'll explain everything step by step, and it'll make sense. So, first thing is we need to, when we do the Rmse, this is root mean squared error. So we have to work backwards, right? We're going to work our way back out to the root here. So we're going to start with squaring the errors. So the first thing we have to do is find the errors, or the differences, right? So we're going to do this for the test set. We'll illustrate this for the test set. When we find the differences, we just have to subtract the values, right? So we take 4 and we subtract the prediction value of 3.5. So 4 minus 3.5. Okay. We do this for this 2 right here, and we have another value 3.5. So we have 2 minus 3.5. We do 5 minus 3.5. So there's 5 minus 3.5. We do 3 minus 3.5. So we have 3 minus 3.5. And we have, finally again, 4 minus 3.5. So 4 minus 3.5. And so now if we can just fill in what that is, right? This is going to be positive 0.5. This is going to be negative 1.5. The positives and negatives don't matter, as we'll see in a minute, but this is 5 minus 3.5. It's going to give us 1.5. This is, so these are just equals over here. And 3 minus 3.5 is going to give us negative 0.5. And 4 minus 3.5 is going to give us positive 0.5. So now we need to square the differences, actually. And before we take the mean, we'll square the differences, okay? So then we take these values and we just square them all. So 0.5 squared is 0.25. Negative 1.5 squared is 2.25. Again, the positives and negatives don't matter because we're squaring the values. And if you don't know what squaring is, it's really just taking a number and multiplying it by itself. Right, so 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16, so on. And so this is really 0.5 times 0.5, which gives us 0.25. This is negative 1.5 times negative 1.5. Then that becomes positive. So again, when you square something, it just becomes positive. This we're going to square, and we're going to get 2.25. This we're going to square, and we're going to get 0.25. And this will square again, and we'll get 0.25. All right, so now we've squared the differences. Now we have to take the mean. So all these values right here, we want to find the mean of each of those values. So now we're up to the mean part. So we did the squared error, now we're finding the mean. So we have 0.25, 2.25, 2.25, 0.25, and 0.25. So we have to add them up and divide by the total number. So there's 5 of them. So we do 0.25 plus 2.25 plus 2.25 plus 0.25 plus 0.25, and we divide that by 5 to get the mean. And so when we do this out, we get 5.25 over 5, which is 1.05 as the mean. Okay, and now finally we have to do the root. So now we square these values to begin with. So now we take the square root of the whole deal, this 1.05 again, to get the final error. So when we take the square root of 1.05, we have square root 1.05, and that gives us 1.0247. So what that's saying is if we multiply 1.0247 by 1.0247, we'll get 1.05. That's why it's the square root. It's just the opposite of squaring. So now that's the Rmse on the test set, and that's how we compute it. We get 1.0247. So for the test set, we'll just write down here 1.0247. And then similarly, we could do it also on the training set, right? So on the values that we do know. So we just did this for these values that we weren't using the predictor. Then how about the ones that we actually did use, the remaining 20? And that'll be much more tedious to do by hand, so we won't do that here. But you can do that out, and you get 1.1619 if you do that. So you just basically, rather than taking the mean over 5 values, you'd be taking the mean over 20 values, which is a lot. But if you haven't already guessed, so this is really great to illustrate the idea of how you do Rmse, and it's the same regardless of what prediction method you're using. But this is a really lazy predictor. So this is just a very simple scheme. We're not taking anything into account, no biases, no nothing, no user-to-user similarities or anything like that. We're just taking a simple mean of everything, a raw average. And so we need to take more things into consideration in order to get this Rmse on the test set and the training set to go down.